According to the National Electrical Code, it is required to identify conductors with color coding to indicate their function. Specifically, hot conductors should be black, red, blue, yellow, or orange. Neutral conductors should be white or grey, and grounding conductors should be green or bare copper. As an electrician, it is your responsibility to ensure that any electrical work you perform complies with the National Electrical Code. This includes addressing any existing code violations, such as unidentified conductors. In this case, you are required to correct certain code violations. Firstly, you must re-identify all white conductors used as hot conductors to indicate their function. Secondly, you must separate hot and neutral conductors in wire mold installations. Thirdly, you must install ground rods for both services to the dwelling. Fourthly, restore the water line bonding at the water meter location. It is not acceptable to use wire mold for installations where the conductors are not properly protected. All exposed junction boxes must have covers. It is strongly recommended that you inform the landlord of the code violations and provide an estimate for the necessary repairs. Explain that these repairs are required by the National Electrical Code and essential for the safety of the tenants and property. You may also consider contacting the local code enforcement authority to report the violations and request an inspection. The National Electrical Code Article 200.4b covers the use of insulation that is white or grey in color. The white or grey colored wire within a cable or flexible cord shall be used for the circuit neutral or grounded conductor only. The exception to this is if it is permanently re-identified to indicate its use as an ungrounded conductor by marking tape, painting, or other effective means at its termination, and at each location where the conductor is visible and accessible. National Electrical Code Section 250.50 discusses grounding. All grounding electrodes together. All grounding electrodes that are present at each building or structure served shall be bonded together to form the grounding electrode system. Where the building or structure is supplied by more than one service or separately derived system, all grounding electrodes shall be bonded together to form the grounding electrode system. The bonding must be completed in the manner specified in National Electrical Code 250.64(3). National Electrical Code 250.52 discusses the made and other electrodes used for grounding. These can include metal underground water pipes, metal frames of the building or structure, concrete encased electrodes, ground rings, and other listed grounding electrodes. It sounds like you have none of these present. National Electrical Code 250.53a discusses the ground rods and pipe electrodes that need to be installed. Rod and pipe electrodes shall not be less than 8 feet or 2.44 meters in length and shall consist of the following materials. Firstly, ground rods of stainless steel and copper or zinc coated steel rod shall be at least 5/8 of an inch or 15.87 millimeters in diameter, unless listed. Secondly, rods of other materials that are listed shall be not less than 1/2 inch or 12.7 millimeters in diameter. Thirdly, pipe or conduit electrodes shall not be smaller than trade size 3/4 inch or metric designated 21, and if of steel or iron, shall have the outer surface galvanized or otherwise metal coated for corrosion protection. Rod and pipe electrodes shall be installed such that at least 8 feet or 2.44 meters of the electrode is in contact with the soil. It shall be driven to a depth of not less than 8 feet or 2.44 meters, except that where rock bottom is encountered, the electrode shall be driven at an oblique angle not exceeding 45 degrees from the vertical, or shall be buried in a trench that is at least 30 inches or 762 millimeters deep. The upper end of the electrode shall be flush with or below ground level unless the above ground end and the grounding electrode conductor attachment are protected against physical damage. National Electrical Code 110.3 covers the examination, identification, installation, and use of equipment. Firstly, the suitability of equipment for an identified purpose shall be evidenced by listing or labeling. Secondly, all electrical equipment shall be installed and used in accordance with any instructions included in the listing or labeling. There are many factors to consider when performing electrical work. Safety and compliance are extremely important. If existing electrical work is not in compliance, it will need to be corrected. Wire mold must be used correctly as well. Wire mold is a surface-mounted raceway system. When using wire mold, you need to ensure that the conductors are properly insulated and protected. The wire mold itself provides a degree of physical protection, but it doesn't replace the need for proper conductor insulation. You should use individual insulated conductors, such as THHN or THWN, inside the wire mold. Never run bare or uninsulated wires inside the wire mold. The size of the wire mold channel must be appropriate for the number and size of conductors being installed. Overfilling the wire mold can damage the conductors and create a fire hazard. Make sure you are using the correct fittings and connectors for the wire mold system. This includes couplings, elbows, end fittings, and boxes. Using the wrong fittings can compromise the integrity of the system and create electrical hazards. Grounding is crucial for safety. The wire mold system must be properly grounded to prevent electrical shocks. Follow the manufacturer's instructions for grounding the wire mold. Wire mold should be securely fastened to the surface using appropriate screws or fasteners. This ensures that the system remains in place and provides adequate protection for the conductors. All connections and terminations inside the wire mold boxes must be done correctly and securely. Loose connections can cause overheating and electrical fires. Use wire connectors or terminals that are appropriate for the size and type of conductors being used. Always perform a thorough inspection of the wire mold installation to ensure that it meets all applicable electrical codes and standards. This includes checking for proper grounding, secure connections, and adequate support. If the existing wire mold installation is not up to code, you should bring it up to code. If there are exposed junction boxes, you need to install covers on them to protect the wiring and prevent accidental contact. The absence of ground rods is a serious safety issue. Ground rods provide a path for fault current to flow to ground, which helps to protect people from electric shock. You should install ground rods as soon as possible. The cut water line bonding also needs to be addressed. Water pipes can become energized if there is a fault in the electrical system. Bonding the water pipes to the electrical system helps to ensure that they are at the same potential as the ground, which reduces the risk of electric shock. Explain to the landlord that these repairs are not only required by code, but also essential for the safety of the tenants and the property. If the landlord is unwilling to make the necessary repairs, you may need to consider contacting the local code enforcement authority. The National Electrical Code is updated every 3 years, so it's important to stay up to date on the latest requirements. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The National Electrical Code is developed by the National Fire Protection Association (NFPA). The National Fire Protection Association is a non-profit organization that develops codes and standards for fire prevention and safety. The National Electrical Code is adopted by most states and local jurisdictions in the United States. It is also used in many other countries around the world. Compliance with the National Electrical Code is essential for ensuring the safety of electrical systems. Failure to comply with the National Electrical Code can result in fines, penalties, and even criminal charges. There are many resources available to help you understand and comply with the National Electrical Code. These resources include the National Electrical Code itself, as well as textbooks, training courses, and online resources. You should consult with a qualified electrical inspector to ensure that your electrical work complies with the National Electrical Code. Electrical inspectors are trained to identify and correct electrical code violations. They can also provide you with guidance on how to comply with the National Electrical Code. It's important to remember that electrical work can be dangerous. If you are not qualified to perform electrical work, you should hire a licensed electrician. Licensed electricians have the training and experience necessary to perform electrical work safely and in accordance with the National Electrical Code. It is very important to properly size conductors for overcurrent protection devices. National Electrical Code Table 310.15b16 gives the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. This table is very important when determining the correct size of wire to use for a particular circuit. For example, a 14 American wire gauge copper conductor with THHN insulation rated for 90 degrees Celsius is rated for 20 amps when installed in free air. However, if this same conductor is installed in a raceway or cable, the allowable ampacity is reduced to 15 amps. This is because the heat from the conductor cannot dissipate as easily when it is installed in a raceway or cable. It is also important to consider the ambient temperature when sizing conductors. The allowable ampacity of a conductor is reduced as the ambient temperature increases. This is because the higher the ambient temperature, the less heat the conductor can dissipate. National Electrical Code Section 310.15b2 provides correction factors for ambient temperatures other than 30 degrees Celsius or 86 degrees Fahrenheit. These correction factors must be applied to the allowable ampacity of the conductor to determine the correct size of wire to use. In addition to the allowable ampacity of the conductor, it is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or not operate at all. National Electrical Code Section 210.19a requires that branch circuit conductors be sized so that the voltage drop does not exceed 3% at the farthest outlet. The voltage drop can be calculated using a variety of formulas. One common formula is the following. Voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant 12.9 for copper and 21.2 for aluminum, I is the current in amps, D is the distance in feet, and circular mils is the cross-sectional area of the conductor. The larger the conductor, the lower the voltage drop. It is important to properly size conductors to ensure that they can safely carry the required current and that the voltage drop is within acceptable limits. Failure to properly size conductors can result in overheating, equipment malfunction, and even fires. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. A ground fault occurs when electricity flows from a hot wire to ground through an unintended path, such as a person's body. GFCIs work by monitoring the current flowing through the hot and neutral wires in a circuit. If there is a difference of more than 5 mA between the current flowing through the hot and neutral wires, the GFCI will trip, cutting off the power to the circuit. GFCIs are required in many areas of the home, including bathrooms, kitchens, garages, and outdoor areas. They are also required on construction sites and in other hazardous locations. Arc fault circuit interrupters, or RFCIs, are designed to protect people from electrical fires. An arc fault occurs when electricity jumps between two conductors, creating a high-temperature arc. Arc faults can be caused by damaged wiring, loose connections, or faulty appliances. RFCIs work by monitoring the current flowing through a circuit for the telltale signs of an arc fault. If an arc fault is detected, the RFCI will trip, cutting off the power to the circuit. RFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. They are not typically required in bathrooms, kitchens, or garages. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges. A voltage surge is a sudden increase in voltage that can damage or destroy electronic equipment. Voltage surges can be caused by lightning strikes, power outages, or faulty equipment. SPD work by diverting excess voltage away from sensitive electronic equipment. They are typically installed at the service entrance of a building, but they can also be installed at individual outlets. It is also a good idea to check for any frayed or damaged wires. Frayed or damaged wires can create a fire hazard or cause electrical shock. Any frayed or damaged wire should be replaced immediately. Make sure that all electrical outlets and switches are working properly. If an outlet or switch is not working properly, it should be replaced immediately. This is just a general overview of some of the basic electrical safety practices. It is important to consult with a qualified electrician for more detailed information. It is also important to follow all local and national electrical codes. Proper grounding and bonding techniques are extremely important for electrical safety. Grounding is the process of connecting electrical equipment to the earth. This provides a path for fault current to flow to ground, which helps to protect people from electric shock. Bonding is the process of connecting all metal parts of an electrical system together. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. There are many different types of grounding and bonding systems. The type of system that is used will depend on the type of electrical system and the local electrical codes. In general, all electrical systems should be grounded and bonded in accordance with the National Electrical Code. Proper wiring methods are very important for electrical safety. There are many different wiring methods that can be used for electrical wiring. The type of wiring method that is used will depend on the type of electrical system and the local electrical codes. In general, all electrical wiring should be installed in accordance with the National Electrical Code. Some common wiring methods include conduit, cable, and wire mold. Conduit is a metal or plastic pipe that is used to protect electrical wires. Cable is a group of wires that are bundled together. Wire mold is a metal or plastic channel that is used to protect electrical wires. Always make sure to work safely and ensure that others around you are safe as well.